So let us start about discussing the distance and section formula. So first I will start with, the distance formula. Before I start, please confirm that you are able to hear my voice very clearly and able to view the screen properly. Please
Yes,
confirm that. Okay, great. Thank you very much. So what is distance formula? The coordinates of 2 points in a plane fix the position of the points in the plane, correct, isn't it? And also the distance between them. Let us understand. Let us, first, draw the coordinate axis. If we draw the coordinate axis, as you know, that this horizontal line, this is known as the x-axis. We name it as x, o, x dash. And the vertical line, perpendicular to the x o x dash is the y-axis, that is y o y dash. Now, 2 points if we take, suppose we are taking 2 points, one point is A and another point is B. Okay. Now, the coordinates of these 2 points, they fix the position of the points in the plane. For example, if we tell the coordinate of the point A, so suppose I write that point A is here. Coordinate of the point A be x1, comma y1, and coordinate of the point B, we say it is as x2, comma y2. So what it says that their position are fixed. As their position are fixed, we can also say what is the distance between them. And what we are going to do now? We are going to find the distance between these 2 points, A and B. Now to find the distance, we will see that value means the line segment AB. If we define the line segment AB, if we draw a straight line between the point A and B, that is the distance between AB. Suppose this is D. What we are going to compute? We are going to compute the value of D in terms of x1, y1, x2 and y2. And how we are going to do it, that we do in the next few minutes. Let us see how to find the distance between these 2 points. Now, as you know, the coordinates of the point, A and B. So what we can say is that we can make some, drawing, and we can conclude this thing. So from the point A, if we draw a perpendicular to the x-axis and if we give this name as P, then what is OP? OP is nothing but x1, correct? Na? And similarly, from the point B, if we draw a perpendicular to the x-axis, and if the foot of the perpendicular is Q, then what is OQ? OQ is x2. So this is x1 as we see, and this is x2. Correct, na, dear students? Similarly, the distance AP is actually y1. If you see the distance AP, this is y1. And in the similarly, the distance BQ, that is actually y2. That is what we have learned from the coordinate of these points, correct or not? Now, what we are going to do, we are going to draw a, we are going to do a construction. So from the point A, we draw a perpendicular to the line BQ, and suppose this point is R. Correct? No? Then what we are going to find? We are going to find the value of BR. So let us write it down. What we get? We get OP is equal to x1, OQ is equal to x2, AP is equal to y1, and BQ is equal to y2. Now from this information, what you can conclude, dear student, is that we can find the value of AR. What is AR? AR is equal to PQ. And what is PQ? PQ is nothing but OQ minus OP. What is OQ? OQ, we just see that x2, and OP is nothing but x1. So from here we get the value of AR is equal to x2 minus x1. Now let us find the value of BR. So in the similar manner, dear students, the value of BR should be what? BR is equal to BQ minus RQ. Sorry. That is equal to BQ minus RQ. What is the value of BQ? BQ value is Y2 minus RQ. RQ is nothing but AP, right? RQ is nothing but AP. AP is what? Y1. So what we get? Y2 minus Y1. So we get the value of AR is equal to x2 minus x1, and the value of BR is equal to y2 minus y1. Now, if you look into the triangle BRA, the triangle BRA is a right angle triangle. So, by applying Pythagoras theorem, in the right angle triangle, BRA, right angle triangle BRA, we get what we are going to get? AB square. AB is the hypotenuse in the right angle triangle BRA. So what we are going to get is that AB square is equal to, we get AR square plus BR square, that is equal to AR square plus BR square. So this implies AB square is equal to, what is AR? AR we found x2 minus x1, that whole square. And what is BR? BR is nothing but y2 minus y1, that whole square. So what we are going to get from here is that AB, that is equal to square root of, x2 minus x1 whole square plus y2 minus y1 whole square. Dear student, generally AB square equal to, if AB square is equal to x2 minus x1 whole square plus y2 minus y1 whole square, then what is the value of AB? AB is equal to plus minus square root of x2 minus x1 whole square plus y2 minus y1 whole square. But AB is what? AB is a distance. It cannot be negative. So we are only considering the positive value, since AB cannot be less than 0. So what is AB? AB is the distance. So what is the value of the distance we get, dear student? We get the value of the distance D is equal to x2 minus x1 whole square. So plus y2 minus y1 whole square. This is the distance between 2 points whose coordinates are given. I repeat, dear students. Suppose there are 2 points. The coordinate of the first point is x1, y1, and coordinate of the second point is x2, y2. Then the distance between these 2 points is square root of x2 minus x1 whole square plus y2 minus y1 whole square. That means square root of the squares of the difference of their x coordinate plus the squares of the difference of their y coordinates. Let us understand by means of an example. Then things will be amply clear. Okay. Suppose we have 2 points. One point is -3, 4. Suppose we have 2 points. Let me use a different color. Suppose we have 2 points. One point is A. Its coordinate is -3, 4. And another point we have B. Suppose here, and its coordinate is 2, -8. 2, -8. And we need to find the distance between them, that is AB. To find the distance between them, if D is the distance, that is D is equal to AB, how to find it out, dear students? D is equal to AB, that is equal to square root of the difference of the x coordinate. So how to do is AB, so x coordinate of the point B, that is 2, minus x coordinate of the point A, that is -3. So you notice that 2 minus of -3, and that is their whole square. So 2 minus of -3, that is whole square, plus what is the y coordinate of the point B, that is -8, and what is the y coordinate of the point A, that is -4, -8 minus 4 whole square. So from here what we get the value, that D is equal to AB is equal to square root of, it is 2 plus 3 whole square, correct, no? 2 plus 3 whole square plus 8 minus 8 minus 4 means what? Is actually, 12 whole square, 12 square. So it is 5 square plus 12 square, that is equal to D is equal to AB. What we are going to get? 5 square is 25 and 12 square is 144. And what we are going to get, that is actually, it is square root of, so this implies D is equal to AB is equal to square root of 169. And what is the value of 169, dear students? The value of square root of 169 is 13. So the distance between the points with coordinate -3, 4 and 2, -8 is 13 units. I hope it is clear.
Yes, sir.
Absolutely clear. Any doubt, never hesitate to. Okay, great then. As you understood. Now, the point is that the distance between 2 points is always positive. Always remember. Okay. The distance between 2 points is always positive. The distance of a point, so let me write down the notes. Okay. So these are the very important notes, and that you should be remembering. Okay. So what are the notes here? Let me write down the notes here. And let me write down the notes in a different color. So the first note, what I can say is that the distance between 2 points is always positive. Distance between 2 points is always positive. Got it? And the second point, what I'm going to say, dear student, is that the distance of a point xy from the origin is equal to square root of x square plus y square. Let us understand. So what is the next point? The distance between the distance the distance between origin and a point P x comma y is square root of x minus 0 whole square, correct na? Because coordinate of the origin is 0 comma 0,
Yes, sir.
that is square root of x square plus y square. Correct na? So here I should write the distance between 2 points because distance is unique. And distance also positive, and also you can say it is unique as well. Correct? And the distance formula, that is, okay, there are total 5 parameters, isn't it? 5 variables. What is the distance formula? If you see d is equal to, or we can say d square is equal to what? We can write x2 minus x1 whole square plus y2 minus y1 whole square. That is the distance formula, na? D square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. Now, if you see, there are total 5 variables here: x1, x2, y1, y2, and d. What are the 5 variables? Okay, so what are the 5 different variables? 5 variables. 5 variables are x1, x2, x1. Okay, if I can write like this, then x2, y1, y2, and d. So these are the 5 variables. And out of these 5 variables, if you know the 4, any 4, you can find the fifth one. Out of these 5 variables, out of these 5 variables, if you know any 4, you can find the fifth one. That means, for example, x1 is given, x2 is given, y1 is given, and d is given. Then you can find the value of y2 from this relation. Now, this is the fundamentals about the distance formula. Now, what we are going to learn is that we are going to learn the distance properties in some geometrical figures. Okay. So, distance properties in geometrical figures are extremely important to know, and that we are going to discuss now. So now, distance properties in some geometrical figures is the point of discussion now. So that I'm going to start in a new page. Distance properties in geometrical figures. Okay. The first consideration, what I'm going to do, dear students, is that is a triangle. Now, if we consider a triangle, okay, ABC is a triangle, then if it is an isosceles, then what condition has to be satisfied? ABC, so this is the way triangle is actually denoted by means of a triangle shape. ABC is a triangle. Now, if the coordinate of these points ABC is given to you, from there you can conclude whether the triangle is an isosceles triangle or equilateral triangle or an right angle triangle. How we can find it out? This triangle will be isosceles if either AB is equal to BC or either AB equal to BC or AB equal to AC or AB is equal to AC or AC is equal to BC. Correct now? That we all know, but as we know the coordinates by using the distance formula, we can find the value of AB, BC and CA. Now out of this AB, BC and CA, if any two are equal, then we can say, yes, the triangle ABC is an isosceles triangle. Now the next one is what? Next one is coming as that equilateral. Equilateral, if AB is equal to BC is equal to AC, then we can call it as an equilateral. And then the next one what is coming is that, so this we discuss about isosceles, this we discuss about equilateral, and this we are going to discuss now is that right angled. Right angled, if any of these following two are going to hold true, AB square is equal to BC square plus CA square, AB square is equal to BC square plus CA square, or BC square is equal to BC square is equal to CA square plus AB square, or CA square is equal to any out of these three. CA square is equal to AB square plus BC square. That means sum of the squares of the two sides is equal to the squares of the third side. Then you can call it as a right angle triangle. We all know this thing from a fundamental definition of isosceles triangle, equilateral triangle and right angle triangle. We know all these things. But here we are revisiting whatever we have learned, but by means of a coordinate point of view. As we know the distance formula, if the three coordinates of that triangle ABC means three vertices ABC are given to us, then we can easily find it out whether it is an isosceles or equilateral or right angled. And dear student, if any of these things are not happening, neither isosceles nor equilateral nor right angle, it is a scalene triangle. All the three sides are different. Correct? Okay, so this is the first point. Okay, that what we can apply of the geometrical figure like triangle. Now the second point what we are going to discuss is that on a quadrilateral. Okay, a quadrilateral is a parallelogram. Okay, if the opposite sides are parallel and equal, right now. But here what we are going to do is that, let's take a quadrilateral first. So I'm going to write it here. So second point is that we see that ABCD is a quadrilateral. Now if ABCD is a quadrilateral, now from there we can say it can be a parallelogram if AB is equal to CD and AD is equal to BC. Correct or not? So from here what we can say is that we can call, it is a parallelogram if AB is equal to CD, if AB is equal to CD and AD is equal to BC. So what kind of shape it is? The shape will be something like this. If you recall the shape of a parallelogram, so this is A, B, this is C, this is D. Correct? So AB should be equal to CD and AD should be equal to BC. So this is the condition that ABCD a quadrilateral to qualify to be a parallelogram. Now the next point is that a quadrilateral is a rectangle. When it will be a rectangle? If it is a parallelogram and the diagonals are also equal. Correct, no? So when we are going to consider this as a rectangle, if means we can say it is a parallelogram, that means if AB is equal to CD, AD is equal to BC and AC is equal to BD. AC is equal to BD. The diagonals also has to be equal. So that means what? This looks like a rectangle. Sometime in the digital board, I face difficulty in drawing straight lines. So what is here? Here is a rectangle A, B, C, D. So, dear student, is that here we are all establishing that whether a quadrilateral is a parallelogram or a rectangle with respect to the distance. So what it has to be? AB has to be equal to CD, AD has to be equal to BC, and the diagonal has to be equal. So if we draw the diagonal, that BD and that AC, that also has to be equal to each other. Then it qualifies to be a rectangle. Now, when we can define it is a rhombus. Okay. So now this quadrilateral will qualify to be a rhombus if all the four sides are equal. Correct? Na? So how we are going to do this thing? So it will be a rhombus. Oh, I can do it a little above. Rhombus if AB is equal to BC is equal to CD is equal to DA. If AB is equal to BC is equal to CD is equal to DA. So that means it looks like something like this. So if it is A, it is B, it is C, it is D. So AB is equal to BC is equal to CD is equal to DA. Then you can call this is a rhombus. Now dear students, that when you can qualify that rectangle to be a square, when it is a rhombus plus the diagonals are actually equal. That we all know from the fundamental definition of our geometry. So what we can say? But here again, we are establishing all these things by means of distance formula. By distance, a square, if AB is equal to BC is equal to CD is equal to DA, and what you can say is that AC is equal to BD and AC is equal to BD. So what will be the structure? It will be a structure something like this. So we get A, B, C, D. So AB is equal to BC is equal to CD is equal to DA, and this diagonal AC and this diagonal BD also has to be equal to each other in order to qualify that rectangle to be a square. So one thing you notice, dear students, is that we can say a rhombus is a square, but the converse is not true. Because why a rhombus? I'm sorry, the other way. A square is a rhombus, but the rhombus is not a square. A square is a rhombus because all the four conditions are actually getting true. AB is equal to BC is equal to CD is equal to DA. So a square is a rhombus. But the converse is not true. That means a rhombus is not a square. Why? Because to a rhombus to be a square, not only four sides has to be equal, the diagonals also has to be equal. Correct, my dear student? Absolutely clear?
Yes, sir.
Okay. Now the last point is that, so this is all about the rectangles. Okay. So whatever we discussed here is all about the rectangles. So let me revisit once more what I said. And these are very important as long as the deciding about this triangle and rectangle is concerned with respect to the distance. So as we just say before rectangle, that if ABC is a triangle and you know the coordinates of the points A, B and C, you can find the length AB, BC and CA. If you see that either AB is equal to BC or BC is equal to CA or AC is equal to BC, then what we can say, you can say is that this triangle is an isosceles triangle. If you find all the three sides are equal, that is AB is equal to BC is equal to CA, then you can say this is an equilateral triangle. Or if you see the sum of the squares of the two sides is equal to the squares of the other side, then you can say it is a right angle triangle. Correct? So this is about the triangle. Now what about the quadrilateral? In quadrilateral, what we see is that first and foremost thing is that a quadrilateral, suppose ABCD is a quadrilateral. Okay. Now that quadrilateral will qualify to be a parallelogram if AB is equal to CD and AD is equal to BC. That means what? Opposite sides are equal. And that quadrilateral will qualify to be a rectangle if not only the opposite sides are equal, the diagonals also has to be equal. So what we can say? We can say a rectangle is a parallelogram because rectangle satisfies all the conditions to become a parallelogram, but the converse is not true. Means a parallelogram is not always is not a rectangle. Why? Because a parallelogram to qualify to be a rectangle, the diagonals also has to be equal. Correct? So that is not always true for a parallelogram. And if it is true, that is along with the opposite sides are equal and the diagonals are equal to each other, we qualify that parallelogram to a rectangle. We can also, a rectangle is always a parallelogram. We can define this rectangle as a parallelogram also. Now the next point is coming as a rhombus. A quadrilateral ABCD will qualify to be a rhombus if all the four sides are equal. Right? That is AB is equal to BC is equal to CD is equal to DA. Now that quadrilateral will qualify to a square when it is a rhombus, plus the diagonals also equal to each other. That means AB is equal to BC is equal to CD is equal to DA, and AC is also equal to BD. Then you can say, yes, this quadrilateral qualify to be a square. So from here what we can say, dear students? A square is a rhombus because a square satisfies all the conditions to become a rhombus. Because what is the conditions to be a quadrilateral to be a rhombus? Is that all the four sides has to be equal, which is satisfied by a square. Now along with that, square also satisfy one more criteria, that its diagonals also equal. So what we can say, dear students, that square is a rhombus, but a rhombus is not necessarily a square always. Correct? And in case we find that in a rhombus the diagonals also equal, then we can say, okay, in that case that rhombus is actually converted to a square. Instead of rhombus, we can say this is a square. This is about the quadrilateral. The next point what we are going to discuss, dear student, is that the distance of any point on a circle from the center of, okay, and that is nothing but the radius of the circle, right? Isn't it, dear student? So the distance of any point on a circle from the center, that is known as the radius of the circle, no? So if we consider the next, one is that about the circle. Sorry, let me use the same red color. So in case of circle, what happens, dear student? If you see, suppose if this is a circle, then from the center of the circle, if you suppose center of the circle is C, and if you take any point on the circumference of the circle, okay, suppose this is the point P1, this is the point P2, this is the point P3, this is the point P4, this is the point P5, this is the point P6, and this is the point P7. What we'll see, for circle, that CP1 is equal to CP2 is equal to CP3 is equal to CP4, that is equal to CP5, that is equal to CP6, that is equal to CP7, and that is nothing but it is called the radius. It is called the radius of the circle. Now, what is a circle? Circle is a curve traced out by a point such that it keeps a fixed distance from a fixed point. That fixed point is known as the center of the circle, and the fixed distance is known as the radius of the circle. Did you get that point, dear student? What I'm saying? So what is a circle? Circle is a curve traced out by a point. Suppose a point is actually being traced out. Means circle is a curve traced out by a point. Means on top of this red, if I draw it in a blue, a curve traced out by a point such that it keeps a fixed distance from a fixed point. So this is a fixed distance. These all are the fixed distances. Correct now? And it is from a fixed point. What is the fixed point? Fixed point is the C. So this fixed distance is known as the radius, okay, which we just see as a CP1, CP2, CP3, CP4, like that. And the fixed point C, that is known as the center. Okay, so this is about the circle. Now the next point, what we are going to discuss is that condition of collinearity of 3 points. Under what condition we can say that the 3 points are collinear? That means they are on the same line segment, and that we are going to discuss now. So that I'm going to discuss here the condition for collinearity of 3 points. Listen very carefully, that is important, okay? condition of collinearity of 3 points. Condition of collinearity of 3 points. That means what? We have 3 points, and we want to discuss that under what condition those 3 points are on the same line. So suppose this is a straight line. Let me draw the straight line properly. Suppose this is a straight line, and on that straight line we have 3 points. The first point is A, second point is B, and third point is C. So under what condition we can say these 3 points A, B, C are on the same line? Okay, if we can say they are in the same line or they are collinear, both mean the same thing. Okay, the points ABC are collinear, or the points ABC are on the same line, represent the same phenomenon. If the sum of them will be collinear, if the sum of the lengths of any two line segments, if the sum of the lengths of any two line segments is equal to the length of the remaining line segment, that means what? We can say AB plus BC AB plus BC should be equal to AC, or we see that AC plus CB. So this is the case for which we can write this thing, or we can write that AC plus CB. So let me use a different color. We can write AC plus CB is equal to AB. In that case, what will be the straight line, the position of these points? This will be A, this will be C, and this will be B. Or it could be, what? Or it could be BA plus AC is equal to BC. BA plus AC is equal to BC. So what it will be? It's straight line if we draw. So this is B, this is C, and a point here is A. So BA plus AC is equal to BC. So these are the conditions for collinearity. You see, dear student, that when you have been given the coordinate of the 3 points, you exactly do not know that exactly what is their relative position. Okay, you can plot into the graph paper and you can find it out. But if you just arbitrarily take the coordinates of the point A, B, C like this, then you will find any of these 3 conditions, either this or this or these are going to be hold true. Okay, so this is all about the the theory, what is required as long as the distance formula is concerned. So what we are going to do now, we are going to solve some problem related to it. So what I will request you, dear student, is that you also open your notebook and let us solve together. And here is the first question. First question is that if the distance between the points, you can write it down and we can solve together. The question is like this: if the distance between the points 5, minus 2 and 1, A is 5, find the value of A. So this is question 1. So how to solve this one? Let us consider the point P as 5, minus 2 and the point Q as 1 comma A. So according to the condition given in the question, what it says? It says that PQ is equal to 5. That implies what? That implies PQ square is equal to 5 square, that is 25. That is equal to 25. Now what is PQ square? PQ square is equal to, you know, the difference of the x coordinate, that means x coordinate of the point Q, that is 1, minus x coordinate of the point P, that is 5 whole square, plus y coordinate of the point Q, that is A, minus of minus 2, because the y coordinate of the point P is minus 2. So what we are going to get? We are going to get something like this, is whole square is equal to 25. So from here what we are going to get? 1 minus 5 is equal to minus 4 whole square is equal to 16, plus a plus 2 whole square is equal to 25. So from here what we get? A plus 2 whole square is equal to 25 minus 16. So this implies what, dear students? A plus 2 whole square is equal to 9. So this implies a plus 2 whole square is equal to 3 square. That implies a plus 2 is equal to plus minus 3. And here is an interesting point. Why we get plus minus 3, right? So a plus 2 is equal to plus minus 3. That means what? That means it says two things, no, dear student? That we can say that either a plus 2 is equal to 3 or a plus 2 is equal to minus 3. If we get a plus 2 is equal to 3, so we get a is equal to 1. And if we take a plus 2 is equal to minus 3, so a is equal to minus 5. Correct? No? So now, dear students, very interesting point. So we get two values of a. Then there is a point that how it is possible to get two values of a. Okay, so that means from the point 5 comma minus 2, so that means if I draw it in a different color, suppose this is the point 5 comma minus 2, this is the point P now, 5 comma minus 2. Is it possible to have 2 points so that the distance whose x coordinate is same and y coordinate is different? Possible? Let us plot it. you know you know we don't need to draw a very exact graph paper, but we can draw it in a just approximation. So let us draw the one. So this is x coordinate, x axis, this is y axis, this is x dash, this is y dash, this is origin. So what is the point 5 comma minus 2, dear student? It will be somewhere here. So suppose this is 1, this is 2, this is 3, this is 4, this is 5, and this is minus 1, this is minus 2. So 5 comma minus 2 will be a point here. So this is the point P, 5 comma minus 2. Now what is the point Q? Point Q is that 1 comma A. So that means x coordinate is 1, but y coordinate sometime it is 1. So where will be 1? Here it is 1. Correct? No? So either this point is Q, okay, or it will be minus 5. 1, 2, 3, 4, 5. It is minus 5. So, or it could be this point. So suppose we can call it as a Q prime. And that is quite possible, not dear student, because if we draw a triangle, if we join them, if we join them, what you are going to get? You get PQQ dash is a isosceles triangle, on which what we get is that the distance between, that P to Q is equal to distance between P to Q dash. So what we get it here, this point is 1 comma 1 and this point is 1 comma minus 5. So this is the justification that why it is possible to have two values of A keeping the distance same. Correct, dear students? Absolutely clear? Well understood?
Yes, sir.
Okay. Now let us solve another problem. Okay. So this question actually came in 1 year in ICSE examination, and here it is. So let me take it to the next page. So the question here is that calculate the distance between the point 7, 3, that is A, 7, 3 and B on the x-axis whose abscissa is 11. Okay, whose abscissa is 11 means what? The y coordinate of the point B is 0. So what it will be? If we draw this one in a coordinate axis, it will be, it will be something like this. If we see, this is x-axis, this is x dash, this is y-axis, this is y dash, and this is origin. So 7, 3, could be a point, it will be something like this. 7, here we can say 7, 3 will be some point like this. So this is the point A whose coordinate is 7, 3. And another point B on the x-axis. So the point B is here in the x-axis whose abscissa is 11. So that means it is 11, 0, because any point on the x-axis, its y coordinate is 0. No? So this is the point B. So why do we need to find? We need to find the distance between AB. So how we can find the value of AB? So that is equal to square root of the difference of the x coordinate between the point A and B, that is x coordinate of the point B is 11 minus x coordinate of the point B is 7, so 11 minus 7 whole square, plus y coordinate of the point B is 0 minus y coordinate of the point is 3 whole square. So from here what we get? AB is equal to square root of 11 minus 7, that is 4 square, plus 0 minus 3 whole square equal to 3 square. And dear students, we know that 3, 4 and 5 are Pythagorean triplet, because 3 square plus 4 square is equal to 5 square. So AB is equal to 5. So we find the distance between the point AB and the B, which is on the x-axis with abscissa 11, is actually 5 units. So always write like this thing is called 5 units while writing the answer. Corrected, your students? So in this way we need to solve problems. So this is all about what I had to discuss as long as the distance formula is concerned. Now